The Diffie-Hellman key exchange is secure against Eve, but someone we haven't considered is Mallory, the attacker who can tamper with our messages. It turns out there is an attack that Mallory can do on the Diffie-Hellman key exchange, so let's see that pop up. Alice generates her secret A as usual, computes G to the A mod P, and sends that across the channel. Now, normally that would get received by Bob, but since we have Mallory here, she can choose to intercept that message and replace it with a different value. And specifically, the value that Mallory will replace it with is G to the M mod P. So Mallory chose her own secret M, computed G to the M mod P, and sent that message to Bob. So Bob expected to receive G to the A mod P. He instead has received G to the M mod P thanks to Mallory's tampering. And Mallory will do the same tampering in the other direction. Bob generates B, computes G to the B mod P, and wants to send this to Alice. However, Mallory is here, she receives G to the B mod P, and she intercepts it, replaces it with G to the M mod P, and sends that value to Alice. So Alice was expecting to receive G to the B mod P, she has instead received G to the M mod P. And Alice and Bob, they don't know that the value has been tampered with. How would they know the difference between G to the B and G to the M? They don't know which one they were supposed to receive. So they're both going to proceed like nothing has happened. So what will Alice do? She will take whatever she received. She thought it was G to the B, but it's actually G to the M mod P. She'll take that value, raise it to the A power, and she has computed G to the A M mod P. That's not correct, but that's what Alice derived. And likewise, Bob is going to take the value he received. He thought he received G to the A mod P, but he actually received G to the M mod P. But he'll take that value, he'll raise it to the B power, and he will derive G to the BM mod P. That's also not the right value. So Mallory has caused Alice and Bob to derive different secrets. Alice derived G to the AM mod P, and Bob derived G to the BM mod P. But it's even worse than that. If you look at these two secrets, Mallory herself can actually derive these two secrets. Take a look at all the values that Mallory knows. She knows M, because she chose M herself. She knows G to the A mod P, that was sent by Alice. And she knows G to the B mod P, that was sent by Bob. Using these three values, she can derive the secrets that Alice and Bob derived. So she can take G to the A mod P, she knows that, raise it to her own M power, and she can derive G to the AM, which is the secret that Alice derived. And likewise, she received G to the B mod P from Bob. She knows her own secret M, so she can derive G to the BM mod P, which is Bob's secret. So not only has Mallory caused Alice and Bob to derive different secrets, but she has actually caused them to derive different secrets that Mallory knows. And now things are really bad. For example, if Alice encrypts some message with the shared key and sends it to Bob, Mallory can intercept it, decrypt it with G to the AM mod P, which she knows. She can tamper with the message however she wants, re-encrypt it with G to the BM mod P, and then send it over to Bob, who will be none the wiser. And then when Bob sends a message, he will encrypt it with G to the BM mod P. Mallory can intercept it, decrypt it, read it all she wants, change it all she wants, and then when she's done, she can encrypt it with G to the AM mod P, send that tampered message to Alice, who will be none the wiser. So Mallory is now a full man in the middle. She has the power to read and modify the communications between Alice and Bob are none the wiser. So we've shown that there is an attack that causes Mallory, someone who can tamper with messages, to break the security of Diffie-Hellman and break the integrity and the confidentiality of any schemes that use Diffie-Hellman to generate a secret key. So this is an attack that can be done on the Diffie-Hellman key exchange. So one big issue with the Diffie-Hellman key exchange is that it is not secure against a man-in-the-middle adversary. using the attack that you just saw. Another way of restating that same point is that Diffie-Hellman doesn't provide authentication. In other words, you have successfully done an exchange with someone, but you don't really know who you did an exchange with. So another equivalent way of looking at this picture that we saw from earlier is that two successful Diffie-Hellman key exchanges happen here. Alice did a key exchange. She thought she was doing it with Bob, but in fact, Mallory stepped in front, and Alice and Mallory did a successful exchange. Alice and Mallory exchanged secrets, and Alice and Mallory both know the secret, G to the AM mod P. So Alice did successfully do a key exchange. She just thought she was doing it with Bob and did it with Mallory instead. And likewise, Bob thought he successfully did a key exchange with Alice, but he in fact did a successful key exchange with Mallory because Bob and Mallory both now share the key, G to the BM. So another way of looking at this picture is that two successful key exchanges happened, but instead of happening between Alice and Bob, they happened between Alice and Mallory and Bob because Mallory stepped in between them. So that's what it means when we say Diffie-Hellman doesn't provide authentication. You don't know if you're exchanging keys with Bob or if Mallory has stepped in front and that you are actually exchanging keys with Mallory instead. One more problem with Diffie-Hellman is that it is an active protocol. Alice and Bob both need to be online at the same time. They need to actively exchange G to the A mod P and G to the B mod P in order to derive the shared secret. It's not possible to derive a shared secret if only one of them is active. So in a scenario where Alice is not online right now, she's on vacation, she's taking a nap, and Bob wants to encrypt something and send it to Alice for her to read later, Diffie-Hellman would not support something like that, and we'd have to design some different schemes to support communication where both parties are not online. So those are some issues with Diffie-Hellman. The first and third bullet points are kind of the same in some sense. They're both describing the man-in-the-middle attack that we just saw, and the second bullet point is a usability issue that we will solve later.